What makes things truly random? Let's investigate the classic prime example of an unpredictable event, a coin toss. Knowing if you land heads or tails is practically impossible. Try flipping 100 coins 100 times, count the number of heads landed each time, and graph it. On your graph, the x-axis should represent the number of heads landed, and the y-axis should represent the number of times that outcome comes up. As you can see from this graph, the data follows a bell curve. Unpredictable and naturally occurring events, like flipping a coin, obey a normal distribution. Primes behave the same way. What do I mean by that? Well, every number has a unique prime factorization. Let's count the number of prime factors in a prime factorization. For example, there are 3 prime factors for 27 and 1 prime factor for 31. This chart shows the prime factorization and the number of prime factors of each number 2 to 100. Let's graph the data. Similar to the coin toss, we get another bell curve. Because the prime factorization graph follows a bell curve like the coin toss, it too indicates randomness. This randomness might well be related to the fact that it is difficult to factor a large number into its prime factors. Realizing that factoring into primes is difficult, 3 men, Ravesh, Shamir, and Edelman, invented the RSA algorithm, which would practically lose the credit card number in a website. This is how they pictured it. It would start out with 2 primes, P and Q. These primes would be very large and could even have 60 or more digits. When multiplied together, they would produce an even larger number, N. P and Q would stay private, while N would be public in the website. Then, N would be plugged in to a formula based on modular arithmetic, which would eventually lose the credit card number in a website. It turns out that it works, thanks to Fermat's little theorem. Because of the theorem, they found out that after this many steps, the credit card number would be recovered. Since P and Q are secret to the public, and because of the difficulty of prime factorizations, the RSA algorithm appears to make internet commerce secure. Even though N is public, no one, other than the internet company, can figure out its prime factors, namely P and Q, especially because N is so big. The so-called Riemann hypothesis, which is one of the Millennium Prize problems, states that each non-trivial zero of the zeta function has a real part of 1/2. But what is the zeta function? It's a function which can be represented as this infinite product, involving the primes. Wait, but what about the RSA algorithm? If the Riemann hypothesis is settled, will it be affected? No one knows for sure yet, but the process of settling this million-dollar question might make factoring easier and possibly affect the security of the RSA algorithm.